When I first look at an equation, one of the first things I think of is what sort of an equation is it? There are categories or groups, and I like to think of these as families. So family members look similar but not the same. There are key characteristics or features of a family, but each particular person in the family isn't exactly the same. And it's the same with mathematical families. They might have each family will have a similar shaped graph and similar types of equations, and they will be solved, the equations will be solved, the graph will be read with particular methods that go with that family. So for example, the easiest or most simple one is the graph of the straight line. So it could be like that, or like that, or like that. So you can see they're all straight lines, but they go through the origin at different places. Their y-intercept is different, their gradient is different. The equations will look something like this. They're not the same, but they're similar, and they have similar solving methods. One grouping of different equations is the polynomials. These are three of the most frequently used polynomials. The first one is an example of linear, quadratic, and then cubic. I can tell that this first one is linear because the highest order term has just got a power of 1. For a quadratic, the term with the highest power on it has a power of 2, and for a cubic, the term with the highest power on it has a power of 3. The linear graphs, as we've seen, will be a straight line. The quadratic graphs are a parabola. Something like that. And the cubic graph will be something like that. The reason why this can be helpful is if I look at a graph, an unknown graph, and I see it's a straight line, then I already know something about what the equation will look like. Alternatively, if I look at an equation, then I already know something about what the graph will look like. I also know what kind of methods to apply to solve the equation. If we look at solving linear equations, here I've got a graph of y equals 2x plus 1. And say I wanted to know the value of y when x is 1. So graphically, I just go up from 1 and I can see that y equals 3. So when x equals 1, y should equal 3. That's a graphical solution that we've just done, which can work on any graph at all. But say we wanted to solve it algebraically, say it wasn't nice numbers, say it was big numbers, say it was inexact. What we need to do is substitute the value of one of the variables in to find the other one. You can only solve an equation when there's one unknown. So we're going to solve it when x equals 1 to find out the value of y. So we substitute in the value of x. So that's our linear solution. Our next example is a quadratic graph and a quadratic equation. I can see it's a quadratic graph because it's got the parabola shape, and also the highest order term is a 2, so that's a quadratic. Say we wanted to find out the value of y when x equals 4. So when x equals 4, y equals what. So again, we can go for a graphical solution, and we can see that y equals 3. We can solve this algebraically with substitution, just the same as with the linear equation. So we substitute our x equals 4, and we're trying to find out what our y is. So when x equals 4, y equals 3. The complexity with quadratic equations comes when we know the value of y, but we want to know the value of x that goes with it. So let's start with this same equation. And say this time we knew that y equaled 3, but we didn't know the value of x. This is more difficult to solve than the linear equations because we've now got this square term on the x, which complicates things. What we do is we substitute in for y, we rearrange to make the equation 0, and then we factorise. This equation has got two solutions. So we're looking for the values of x that will make this equation equal to 0. So remember, there's a multiply in there. So when we multiply anything by 0, the result is 0. So one of the solutions is x equals 0. And to make this factor 0, we would have the value of x equals 4. So when x equals 4, the second factor will be 0, resulting in the equation coming to 0. So on the graph here, we can see when y equals 3, we have two values that x can be. X might be 0 or x might be 4. The last type of graph I'm going to look at is exponential graphs and exponential equations. An exponential graph has this very rapid growth curve. Just gets quicker and quicker and quicker. The growth gets quicker and quicker, and the gradient gets steeper and steeper and steeper. In the equation, the variable is the power, and that's what gives the graph its distinctive features. So let's say we're looking at when x equals 3. And we can solve this graphically. We can see that y equals 8. We can also solve it algebraically. So we're going to substitute x equals 3 and find out our value of y. Just like with the quadratic family, we need a new technique when we know the value of y and we want to find the value of x that goes with it. So if we come back to this equation and say we know that y equals 8, but we'd like to know the value of x that goes with it. To solve equations with exponents, we use logs. So there's using logs to solve the equation algebraically so that when y equals 8, x equals 3.